also Dr. Matthew Laurence. Matthew has a PhD in plant pathogen evolution, 15 years experience at the Botanic Gardens of Sydney, managing the plant clinic. He runs an arboriculture consultancy and is an accredited arboriculturalist and serves as a senior editor for the Australasian Plant Pathology Society Journal. The presentation this afternoon will be on Phytophthora in urban tree planting stock. Are we managing the risk to urban forest and natural ecosystems? If you want to come up, thank you.
Well, thank you for that kind introduction, and also Adrian for that great talk. It was really motivating personally for me. So today I'm going to be talking about our main research project, which is about the plant pathogen Phytophthora in our urban tree planting stock. And I want to ask the overall question, are we actually managing that risk adequately? So this is the Plant Clinic Laboratory based in Sydney. We have services for diagnosing a number of different diseases, and all this revenue goes towards our modest research program, which I'll be talking about today. So you might all be experts, but I thought I'd give this sort of basic slide. So what is Phytophthora? So the name gives us a clue. It's Greek for plant destroyer. And there are over 250 described species globally, and with only 91 currently reported in Australia. So I think this is a really important point, and I'm going to come back to this later in my talk. So it's a microscopic organism, and it does resemble a fungus. So this is the hyphae of Phytophthora cinnamomi. So it does look like a fungus, but it's actually in a different kingdom. So it's very different. And this is important as well because traditional fungicides are not effective. It has a complex life cycle, so it produces lots of different spore types. But I've divided them into resting phase and infective phase because these are really important to understand the management. All right, so this figure tries to show how Phytophthora spreads from an infected tree to an uninfected tree. And I'll start talking about the infective phase first. So when you have high rainfall and high soil moisture, an infected root will produce these sporangia. And within each sporangium, there are between 20 and 40 of these motile zoospores. And when these are released, they can swim, and they can swim distances between 5 and 10 centimeters. But they mainly move passively in the interstitial soil, and that's with gravity, so they move down slope. But the take-home message here is that as long as it stays wet, this is polycyclic. So you can start with a very small amount of inoculum, and in a short period of time build up masses of inoculum. And when I mean short period of time, it's 12 to 24 hours. So you really need to think about this when you're walking through infested national parks after rain, because those pools of water will be literally full of zoospores. Now, if Phytophthora stopped there, it'd be quite easy to manage, but it has this resting phase as well. So it produces these thick cell-walled spores called oospores and chlamydospores, and they can persist in the soil for many years under the right conditions, and they're spread passively through the movement of infested roots and soils. And in the Bunyan National Park, they're being spread by pigs as well. So take home, it's easily spread and cannot be eradicated. Right, so how does Phytophthora kill? Well, it infects those fine feeder roots. So you can see here a control, nice healthy root ball, and then there's almost no feeder roots at all. And so you can imagine because of this, the above ground symptoms mimic water stress and or nutrient deficiencies because the plant cannot uptake enough water or nutrients. This is sort of Plant Path 101, the disease triangle, but we always get this question in nurseries. So our plants look really healthy, so therefore they can't have Phytophthora, and if they do have Phytophthora, why does it even matter? So the disease triangle just says that in order to get disease, you have to have a virulent pathogen, a susceptible host, and a conducive environment. And it's obviously a massive oversimplification, but it's quite helpful to understand the disease and manage it. So here's just an example of a non-conducive environment. So this Lophosamon is growing in a nursery. It's actually infected with Phytophthora, and there are virtually no above ground symptoms. There's maybe some slight chlorosis, but you move that into the urban environment, a very harsh environment, and the tree rapidly succumbs. This is an example of a non-susceptible host. So you have a very healthy root ball, and it's still infected with cinnamomi, but obviously a susceptible host will die. Now this is really important because if you plant a non-susceptible host that's infected with Phytophthora into an environment, it will spread from that non-susceptible host to susceptible hosts, and you will start getting disease. So this is actually quite a critical part. Okay, so in summary, the symptoms mimic water stress and nutrient deficiencies, but there can be no symptoms at all. And so Phytophthora infection can be hidden. Right, so why is it important for conservation? You probably already know this, but it's considered a biological bulldozer and a key threatening process. And this is mainly because it has a very wide host range, so it can change entire plant communities, and it often replaces susceptible species with rushes and sedges. And of course, this indirectly affects the fauna that's dependent on that habitat. And this is just reproduced from Kearney, and it just ranks invasive species based on their impact. And Phytophthora cinnamomi is ranked second to the European rabbit. And I'd just like to point out that this is one species of Phytophthora, and there are over 300 species globally. So the impact at the genus level is much greater than this, or potentially. This is just a little case study to summarize everything I've talked about so far. So Sarah and I went to the Barrington Tops earlier this year to this high altitude wetland. And if you were to look at this landscape, you'd think it looks pretty healthy. But as soon as you put the drone up, you can see this high tide of dead Epacris. And this was associated with Phytophthora cinnamomi. And what we think's happened is it's moved down this creek line, there's been a flooding event, and it's spread up slope and it's killed these plants. So this summarizes everything I've been talking about, because here you have an introduced Phytophthora species. You have waterlogged soil, so it's conducive to the production of zoospores. You have a sloping site on a drainage line, so these zoospores are going to move down slopes into uninfected areas. This is changing the entire plant community, and the Epacris is actually key habitat for the broad-toothed rat. And then, as we know, it produces these resting spores, so this will be a disease of sight now, and that limits restoration options going forward. So I doubt you could ever really plant Epacris here again. Okay, so on to the actual Stop the Rot project, the origin. So if you've been in Sydney recently, you would have seen millions of trees being planted into the urban forest, and this is to combat the urban heat island effect. And we had a number of councils reporting tree establishment failure, and when we investigated, it was always associated with Phytophthora. So that really begged the question, how big a problem is it in our amenity tree nursery industry? So we did a survey, over 1,400 trees, both natives and exotics. And these were sourced from 2 community nurseries and also 4 commercial nurseries. So we were anticipating about 7% incidence, but we were quite shocked to find that it was actually 23%. And there are about, I think they're estimated 5 to 6 million trees going in over the next 10 years, so there's going to be a lot of infected trees entering into the environment. And this is even more concerning when you look at the species we detected. So this figure is just the phylogenetic diversity, but I've summarized the key points here. So we detected 13 described species across 6 clades, including cinnamomi and multivora. There were novel lineages, probably new species, and there were 2 new reports. And one of these reports was Phytophthora mediterranea, and that's considered a biosecurity concern because it causes disease on myrtaceae in Europe. So it's a bit sobering. So this is the paper, it's open access, so if you want to access and read more, you can. So I guess you're probably asking, why does Phytophthora in the urban forest even really matter to plant conservation more broadly? Well, we're starting to understand that the urban forest is actually a center of diversity for Phytophthora, and that this population is a bridgehead into natural ecosystems. And I'm just going to give a few examples, recent examples from the plant clinic. So obviously everyone's aware of Phytophthora multivora in Bunyan National Park. This species was probably introduced from South Africa and had spread, and we were just doing field work last week, so shout out to Paul and everyone else from BPAC for the hospitality. And it was really good for us to get out of the lab and see not only the impact on the trees, but also the cultural impact as well. So this one's a little bit closer to home. So this was a garden bed planted outside the plant clinic about a year ago with camellias, and they never really thrived and they started to decline. So we tested them and they detected they were positive for Phytophthora multivora. And then we've also been fishing for Phytophthora in nursery dams, and we're detecting multivora as well. So doesn't prove the cause, but it's really a smoking gun. This is another one from this year. It was at the Blue Mountains Botanic Gardens. There was a wilting rhododendron, and so we know that it does cause these wilt symptoms. So we did our methodology and we detected Phytophthora plurivora in Australia for the first time. So this is a closely related species to multivora, and it does cause forest declines in Europe. About a year later, there was this reported dieback event on dwarf mountain pine at Wentworth Falls and also in Toowoomba. And we got some climbers in. I wasn't game to go up there and take those samples, but we sent some climbers in and they took samples and we detected plurivora. So it's really like a sort of smoking gun again, I guess. All right, so I guess that begs the question, how clean are our restoration planning programs in New South Wales? And I don't think we really know just yet. So we've started that survey and we've surveyed 3 SOS planning programs and all 3 have been positive so far. So I'll just let that sink in a bit. Okay, so it's been a bit negative, so I want to end on a sort of positive note. So can we even reduce Phytophthora in our nurseries? I'm going to just give the case study from California. So they had Phytophthora ramorum introduced from Europe via the live plant trade, and it was spread by the live plant trade. And it's moved into natural ecosystems and it's killed 40 to 50 million tan oaks. So if you've been through California, you would have seen this happening, and it's quite shocking. But what they did is they went and looked at their restoration nurseries. They found that they were heavily infested, and they developed these best management practices and an accreditation program to produce native plant nursery stock free of Phytophthora. So their goal was to eliminate it. How did they do? So they went back and did a survey post over a number of years, and they found that non-compliant nurseries still had a very high incidence. Partially was 25%, so about where we're at in amenity tree nurseries. And then compliant nurseries had no Phytophthora despite 20,000 tests over multiple years and multiple nurseries. So these guidelines do work, and we can eliminate Phytophthora from our nurseries. We just have to have the will to do it. All right, so where does Phytophthora come from in our nurseries? So there's multiple sources. So it can be infested soil and potting mix, vehicles, nursery workers, infested stock's a big one. But what we're finding is infested irrigation water is a huge one. So if you're irrigating from dam water that's not treated, you're going to be pretty much dosing your plants with Phytophthora every day. And then once it gets into that nursery environment, the conditions in there amplify it. And I mentioned earlier, it is microscopic and there can be no above ground symptoms. So really the only way to know if you have Phytophthora and where it's coming from is to test. So that's the first step in any management program. Okay, so this is our little thing. So we've been working on this for a number of years now, and we've partnered with EcoPath Solutions to come up with a system for detection in nurseries that meet these 4 criteria. And the first, it has to be cost effective, so it has to be cheap per plant. It has to be automated, scalable, because the industry is obviously enormous, so we need to scale it quickly. And it has to be comprehensive, so capable of testing plants, water, and soil, so all the different sources. And we also hope it can be used for delimiting surveys in national parks. And it works as 3 main stages: irrigate, concentrate, and test. And this is what it looks like. So these are all the different components of it. I don't have time to go into how each part works, but please see us afterwards and we can talk about it further. Now, this is another project we're working on. It's a story for another day, really, but it's for detection of Phytophthora at the landscape scale. So we're training these ecological scent dogs, and this is just Alice and I having a day on the beach in Lord Howe Island. And it wasn't exactly how I imagined it, but we still had fun. And she's so earnest, she just wanted to keep working. And I was like, can we pack it in now already? Anyway, yeah. So that's it. And thank you to all the team at the Botanic Gardens and all the people who have supported the project. Thank you.